Hi, this is Tom, and we just finished looking at the binomial experiment where there's only success or failure. Now we're going to look at the multinomial distribution where you can have multiple successes. And here's our problem. It says, a bag contains 3 red marbles, 4 green marbles, and 5 yellow marbles. Find the probability of selecting 2 red, 2 green, and 2 yellow marbles. After a marble is drawn, the result is recorded and the marble is returned to the bag. And in general, we would call that with replacement. Oops, it's not ugly W. With replacement. Well, the way to approach this problem is the same way we first have approached any of our problems, or the way we approached the binomial problems in the last section. And that is solution. Let's write this. Our solution comes from first write one example of success. Just one. That's all you have to come up with, not more than that. So for example, as simple as this may sound, I may just draw them exactly in the order in which we wrote the problem. I may pull 2 reds, 2 greens, and then 2 yellows. So I'm going to record that as red with an R. So say I draw a red, then I draw another red, then I draw a green. And remember, then I put the green back into the bag, and I draw another green. I record that and I put it back in the bag, then I draw a yellow and a yellow. Now, that may seem like a small step, but it's not. Because notice this, RRGGYY is a word. So what we're going to do in a moment is multiply by the number of words. So we'll do that in a moment. So here we go. When you first draw a red marble, notice that there is, let's see, make a little note here. Notice that we have 3, 4, 5. So we have 3 plus 4 plus 5. So that's 7 plus, that's 12 marbles in the bag. So we have 12 marbles. Well, all right. So the probability of drawing a red initially is 3 out of 12. But then we record the result and we return the red to the bag. So the probability of the next red is again 3/12. And then we return that red, we record the R, return it to the bag, and so the probability now of drawing a green is 4/12. And we continue this problem, or this process, and then we get to the yellows, and we have 5 of those, so that's 5/12. Times. Now, this is only one way to succeed, but we need to make sure we get all possible ways to succeed. Well, that's the word. And notice we have 1, 2, 3, 4, 5, 6 letters, so that's 6 factorial. And then we have to divide it by 2 R's, that's 2 factorial. 2 greens, that's 2 factorial, and 2 yellows, that's 2 factorial. And if we put that in our calculator, we multiply it all up, we could probably do that here for you. Let me just do this, and we'll just run through it. For those of you that like doing these by hand, which is kind of fun, let's copy that. I'm going to put it right back down below it, because I'm going to write on this one. And that would be, let's use a different color, because I'm going to make some corrections. And notice that 3 times 4, that's a 12. Okay, let's do another one. How about a red one? 3 times a 4, that's also a 12. Okay, and then let's do another color. Notice that 6 factorial is the same as 6 times 5 times 4 times 3 times 2 times 1. All right, well, here's a 2 factorial that we can cancel out. Let's cancel that 2 times 1 with that 2 times 1. And then I have a 2 times 1 times 2 times 1. Well, this is really just a 4. So I can cancel. So let's see. It looks like I can cancel that 4 with that 4. And let me see. Oh, and I've got some more. Here's another one we could try in pink. Here's a 6. Let's see. I've got a 6. So let's cancel a 6. That'll make this a 2. We can cancel here another color. Let's keep track. Blue. Cancel that 3. That makes a 4. And there we go. I think we can put it all back together now. Notice in the numerator I have a 5 times a 5 times a 5. That's 125. And in the denominator I have a 2 times 4. That's an 8. Times a 12 times a 12. I don't think there's any more reducing we can do that. So 8 times 12 times 12. This gives me 125 over 1,152. And that is the probability of pulling 2 red, 2 green, and 2 yellow marbles from the bag with replacement. That's the important part. Now, one thing to note is the multinomial distribution is quite common. However, it's not one that's in your calculator. This is actually just one where you need to write out that one way to be successful, write the associated probabilities, multiply them together, and multiply it by the number of words possible from your success. In the next video, we're going to look at what happens when you don't put the marbles back in the bag. See you then. Thanks for watching.